Okay, we're going to spend a couple of minutes talking about distance, speed, velocity, what all those things mean, because for this week, we're going to learn how to calculate speed by using the distance over time formula for speed. And we're going to talk about how to read and interpret and understand some of our different motion graphs, which include speed and acceleration. So if you think about distance for a minute, and you take a look at the examples that I have here on the slides, you're going to see that when we're discussing distance, we're looking at how far an object travels. Now, in this case, we have a centimeter ruler, so we know that we're traveling in centimeters. We're going to be using metric system, so we'll be using millimeters, centimeters, and meters to measure most of our measurements. When we look at the distance of an object, it will not be dependent on direction. What this means is that we're only looking at how far the object travels. It doesn't matter what direction the object is traveling in. So if we look at our ant here that's traveling across this ruler, you'll see that the ant traveled a total of 3 centimeters based on where this arrow shows the ant stopped. So keep in mind, again, distance does not depend on the direction that we're going in. So if the ant, once again, is moving, what distance would the ant be traveling this time? So let's say the ant goes back to our 0 centimeters. The ant would, of course, be traveling once again 3 centimeters. Does the direction change this answer at all? And the answer is no, it does not. So keep in mind, distance does not depend on direction. And let's see what our ant does this time. Notice the ant here travels 5 centimeters and then travels 2 more centimeters from 5 to 3. So if you add these measurements up, that's 5 centimeters and 2 more centimeters, which means the ant is traveling a total of 7 centimeters. Remember that distance does not depend on the direction. When we start talking about speed, we are looking at a rate measurement, and this is the rate at which an object is moving. So we measure speed with the formula of distance over time. Distance is typically measured in meters, and time is typically measured in seconds. Once again, to remind you, just like distance, speed is not going to depend on the direction that the object is going. So, if a car happens to drive 100 meters in 5 seconds, in order to get the speed of that car, you would take the 100 and you would divide it by 5, because speed is distance divided by time, and you would get 20 meters per second. Notice that the units of measure are mentioned on here. That's very important for you to remember. A rocket happens to be traveling 3,000 meters in 300 seconds. What's the speed of the rocket? Let me go back to that one real quick. If we take a look at this measurement, 3,000 meters and 300 seconds, we know that speed is distance divided by time. The distance is 3,000 divided by 300. If you divide these two, obviously a really quick and easy way to do this would be to take off 2 of the zeros. And if you did that, you actually have 30 divided by 3, which would be 10 meters per second. Now to talk about velocity for just a minute. Velocity is the same as speed, except you're adding direction. And what that means is that it not only has a magnitude, which is that measurement, but it also has direction. So just like you calculated speed before, if we look at our ant traveled 5 centimeters, and the time it took was 10 seconds. Its speed would have been 0.5 centimeters per second. Now, If you notice, it's traveling east, and we have that added measurement back here that gives us our velocity. Anytime you add direction to speed, it then becomes velocity. Velocity is speed and direction.